My name is Josh Long. It is so good to be before you this fine morning, or in your case, evening. Thank you so much for coming out. My name is Josh Long. I work on the Spring team. I have been the first Spring developer advocate since 2010. I'm a Kotlin Google developer expert, a Java champion, and most importantly, I'm at your service. So if you have questions, when ineluctably you have questions, please don't hesitate to reach out to me. I'm on Twitter. I am on LinkedIn. I have email. I don't know if anybody uses email anymore, but there's a thing. I have not one, not two, but 3 different blogs. I have a book called Reactive Spring, YouTube series that you can find at bit.ly spring-tips-playlist. And the code for that there is also on GitHub. And I have a podcast every Thursday, my time, Friday for most of the eastern, part of the world, everything east of California. I have a podcast that comes out, and it's just me talking to people that are smarter than I am. So it's a very fun show. And I'm on Twitch as well. So lots of places where you can find me if you have questions beyond this time we have together. Today, my friends, we're going to talk about some of the latest and greatest in the Spring ecosystem. Spring is at a very important point in its storied history. Remember, the first lines of code for Spring were written in 2001, right? So by that measure, there's been some kind of code that would become Spring in some form for more than 20 years. And Spring has survived and thrived. It has become as good as it is because it constantly adapts to meet new paradigms, new challenges, new opportunities, new frontiers. And I think we're at another such inflection point. There's a reason that Spring Boot has made Java relevant in the cloud. It is the original cloud native technology, right? It is the most natural thing to use in the cloud these days. And that is because it has constantly grown to change. We are facing the end of the year now. Summer is almost behind us. In less than a month, it'll be behind us. And as we look forward to later this year, we have Spring Boot 3 and Spring Framework 6. These are new generations of the Spring Framework and the Spring Boot project that bring with it lots of exciting changes. And so we're going to see some of those changes. We'll talk about them. We can't really demo all of them yet because they're not there yet, but we can talk about them and we can kind of see what those things will look like. And we're also going to talk about the latest and greatest changes today in the world of Spring. And to do all of this, of course, we'll go to my second favorite place on the internet, start.spring.io. My first favorite place, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a new application called Customers. We're going to use Spring Boot 2.7.3, the latest and greatest version of Spring Boot. And then we have down here, we have a choice of what version. Then we have the version of Java that we want, right? And here, my friends, we already have the first interesting point. Spring Framework 6 due later this year, and Spring Boot 3 will assume a Java 17 baseline, okay? Now, here, Java 17 is the current default selected version. It is an amazing piece of technology. I love Java, and I love the amazing innovation that's happening in the Java space. Java 17 is the current long-term supported version of Java. It's also the most technically superior version of Java compared to anything that has come before it. It's faster, more performant, more syntax-rich, more observable, more operations-ready in every way. It's also morally superior in every way. You will not like the look of sadness and despair in your children's faces when they see that you're using Java 8 in production. Don't do it. Do the right thing. Be the change that you want to see in the world to use Java 17. And judging purely by the version number alone, Java 17 is more than twice as good as Java 8. I think that's a fact. So there's a lot of reasons to use Java 17. It is also the baseline version that you have to use in order to use the next generation of Spring. This version brings with it a assumed baseline of Java 17, which might sound kind of aggressive, but think about where we are in the history and the evolution of Spring relative to Java. When we released Spring Framework 5 in 2017 in September, so almost 5 years, we used Java 8 as the baseline. That was half a decade ago, 5 years ago. And now we are saying we must use Java 17. But consider that Java 17 is no longer even the current version. There's already Java 18. By the time Spring Framework 6 comes, there will be Java 19. So there'll be 2 versions of Java already by the time Spring Framework 6 arrives later this year. And we cannot see the future, but if we say that there are 5 more years of Spring Framework 6, as there were 5 years of Spring Framework 5, then the next version will come in, 2028, right? I mean, we don't know, 2027 at the earliest, I guess. I don't know how long the Spring Framework 6 lifespan will be, but if it's 5 years and there's a new release of Java every 6 months, that's 10 versions. That means that we have 12 versions between now and Spring Framework 7 or something like that, right? Roughly. I don't know. We have no idea. But just think about that. 12 different versions, right? Between 17 and whatever the new baseline is. That's Java 29, right? That's a long, long way from now. And so Java 17, even though it seems like a very high version today, it's not. It's already not even the current one. It's old now. And in 5 years, it will seem impossibly old, right? Very, very old, almost double. Not quite, but almost, right? So I love Java 17. It's the new baseline. The other thing that you should know is when we release Spring Framework 6, Spring Framework 6 will incorporate the latest Jakarta EE APIs. Now, I don't have time to get into all of this, but the Jakarta EE projects were born out of politics, right? And these politics were such that they are now open source, which is great. It's a great move, and they now live at the Eclipse Foundation. But in order to make it work, they had to agree to not use the existing packages. So JAVAX dot Javax, right? Javax dot JPA dot validation. What all those packages that you know from Java EE, those packages now change for any new code, for any new methods and types, which is to say all things eventually. Those packages now change to Jakarta dot asterisk. Okay, so Jakarta dot validation and Jakarta dot JMS and so on. This is going to break code, obviously, and it cannot be helped. It cannot be avoided. Thankfully, it's not a very hard fix because the people working on Jakarta EE have done a very good job of giving us a backwards compatible version that we can move to. So there's one version that looks like this, another same version, just with a different package, no new changes really. And so nothing breaks. As a result, it's very easy to do a find and replace and update your code. You should be aware of this. This is nothing that we can do to fix this. It's just the situation that we are in. And all the other projects are also updating. So Hibernate and all your favorite message queues and Apache Tomcat and Jetty, all of them have upgraded to the new packages as well. This is an easy change, but it's going to be it's going to cause some work, right? It's not a lot of work. It's not hard work. It's find and replace, but it's going to be there. So Spring Framework 6 is a big deal because of the new assumptions about baselines. Okay, so we're going to build a new application. We're going to be using the reactive web support. We use H2, we use R2DBC. We're going to use the Spring Boot actuator. We're going to use Lombok, and we're going to use Spring Native. Okay. Now, Spring Reactive Web, H2, Spring Data, R2DBC, the actuator, Lombok, and Spring Native. Most of these are reactive, right? Reactive Web, R2DBC, etc. These are, reactive programming is a style of programming that makes it easy for me to get 3 big benefits. Okay. Those, let me see. Those benefits are, one, a more streamlined programming model that makes it easier for me to write safe, robust, scalable code. 2, ease of composition, because I have one abstraction and I can compose those different streams in any way I like. I don't have to think about the life cycle and the speed and the cadence of the data. It's all one kind of thing. It's all one type called a reactive stream, a publisher. And the third benefit is that because we have a single abstraction, we have a single place, a natural central place to put things to support reliability concerns, things like retries and timeouts and back pressure and so on. So I like reactive programming. We're not going to talk about it all that much here. It's not that important for what we're trying to look at today. We're just going to build an application that talks to a database. And in order to do that, I'll create an entity that has a ID field like this. And it's going to be a record. Look, it's a it's a record with getters and constructor and all that stuff. No lombok. Isn't that awesome? So interface customer repository extends reactive CRUD repository manager. Okay, integer. Good. And now I want to export all this data. So I'll create an HTTP controller, and I'll inject that customer repository like so. Okay, and I'm going to create a constructor there at get mapping customers publisher. Okay, customer. Good. So this dot find all. Good. Okay, so there's my reactive HTTP controller. I'll make this a at controller at response body. Good. And I'm going to install some data. I need a schema. So I'll create a file here called schema.sql, like so. I'll say create table customer ID serial primary key name varchar 255 not null. Okay. So let's install some data. So I need to actually have a bean that will start up when the application starts, and I'll just use it to initialize my database. Okay, so I'm going to inject this customer repository that we just created here, and customer repository, and I'll say var names equals, and I'll just say okay, and some people on the Spring team. I've actually got 2 Olegs, believe it or not, and Artem, and Olga, and Violetta. Just amazing engineers on the Spring team. Who else could I put in there? Goodness, Madura, of course. Stefan. There we go. So just some names. Is that we need Yushin. There we go. We've got 8 names, and now for each name, I'm going to map it into a new name, and I'll write it to the database. So I'll say new customer null for the ID name, and I'm going to write each one of those to the database. I'll say repository.save C, and then I'm just going to subscribe to the whole thing just to kick off the pipeline, right? So, so there's this whole. There you go. So there's the entire pipeline. Okay, response, and I'm going to kick this off, and let's just see what happens. We'll run it. Good stuff. I want to see what actually happened. I want to see the results of the persistence. I'll overload that. I use that overloaded method there. Okay, restart. Good, it's worked. So we have 8 records in the database. If we go to localhost customers, you can see there's the data. It worked. Of course it worked. It was a demo. It was always going to work. That's not what we're here to talk about. What I wanted to talk to you about is how to get this thing into production. Anybody can build a web application. But when we build an application, we want to be able to observe it. And so, of course, to support that, we have the Spring Boot actuator. The actuator gives us details about the application that make it easier for us to move that application into production, where today, more often than not, Kubernetes is production, right? So let's go ahead and restart this. And when we restart the application, we'll get this actuator endpoint. There we go. That has all the different endpoints that give us information about the application. You've got the metrics endpoint, which gives you statistics. This is powered by Micrometer. Micrometer is a vendor-neutral application metrics facade. You've got the ability to use Micrometer to talk to different time series databases, including Prometheus. We have the health endpoint, which contains information about the health of the service and the different subsystems. You can look at the source, it's just like this, but I've got a browser plugin, of course. It gives us information about the different health states, the state of the subsystems of the application. In Kubernetes, there's 2 particular kinds of health checks. One is called a readiness check. The readiness check tells the Kubernetes orchestrator whether the service is ready to be put into production. And the other one is liveness. And so we already have those. We have readiness, right, and liveness. And of course, these are specifically meant for you to use in deploying your application to Kubernetes via a pod. Okay, so we have those there. Now, what happens if this says that the service is sick? What if it says down? Okay, you'll get a status code 500. and not just 200, you'll get a 500 error code. And now the service is sick. Kubernetes needs to deploy a new instance of the pod and take the old one out of the rotation. In order for it to do this, it will shut down the existing application. But what happens to anything that you are doing in the existing application? What if you are handling many web requests at the same time? Does that all just get lost? Yes, it does, unfortunately. So you need to make sure that you use graceful shutdown. Okay, so graceful shutdown. And what this will do is it'll delay the closing of the application context for, in this case, 30 seconds, and give you a chance to figure out what to do with any in-flight transactions. If you have HTTP enabled, it'll stop accepting new HTTP requests for you, and it'll let you finish any in-flight work for up to 30 seconds. So it's the difference between SIG-term and SIG-kill, right? The container orchestrator Kubernetes will send SIG-term asking your application to shut down gracefully, and then after 30 seconds, it'll kill the process and force it to shut down, right? So this gives you a chance to respond to those lifecycle changes in Kubernetes. Okay, so now I've got an application that's more or less ready for production. There's a lot we could talk about there with the actuator. I need to get this to production, but I want to turn it into an application that works well in production. And there's two concerns here. One, let me stop this. One is I want to turn this into an application that behaves as efficiently as possible in production. Java is an amazing piece of technology. You heard me talk about it earlier. In the history of Java, however, whenever there is a choice between efficiency and speed, Java has always chosen speed, right? And this means, and this is not entirely its fault, but it has always chosen speed, has prioritized that over efficiency. And that's partly because Java is kind of, their hands are tied, aren't they? They have a very dynamic runtime. This runtime means that Java is actually more like JavaScript in Ruby and Python than it is C or C++. It's a very dynamic thing. You can do reflection, you can do serialization, you can do all these things that the compiler cannot see at compile time. And yet somehow it's also very fast. It includes a full adaptive just-in-time compiler that ships in your production code that takes code that's run frequently and compiles it into native code. This is called a just-in-time compiler. This mechanism is amazing. It's one of the reasons that Java is so popular and so powerful, is because a mediocre, basic Java application can sometimes be more efficient and more performant, rather, than a C or C++ application written by somebody with more skill, just because of this amazing runtime garbage collector and just-in-time compiler. So there's a lot of benefits to that just-in-time compiler, but if it's so good, then why don't we just have that for everything? Why can't we just proactively compile everything? Why do we have to wait for it to be used many times at runtime? And that's the idea behind an ahead-of-time optimizing compiler. GraalVM ships with an ahead-of-time optimizing compiler. The problem is, again, that in order for this optimizing compiler to do its work, it has to make Java more like C and C++. It needs to get rid of or account for some of the very dynamic behavior in Java that make it similar to JavaScript and so on. And so in order to do this, you need to provide configuration. Because remember, GraalVM hates your Java code. It hates everything about it. It wants your code to look like C, or at least in terms of like the guarantees that the compiler can make for the runtime version of that code. So in order to do this, you need to provide configuration, lots of configuration, for any dynamic things you might do. Serialization, if you load a resource from a jar, if you load a class via a class loader using reflection, if you invoke methods, if you do proxies, any of this stuff, you need to provide configuration. And of course, all programs do this at some point. They do something like this. I mean, even if you're just loading a property file, you need to tell GraalVM about this. So we have a project called Spring Native. Spring Native is for today. It's for Spring Framework 5. In Spring Framework 6, we will have built-in support in Spring Framework. You won't have to use a separate project, and the support will be even better in Spring Framework 6 and in Spring Boot 3 for native code, for building native applications using your Spring Framework code base. And so we can use that today. I've already got that in the class path. And while some of the things conceptually are the same in Spring Framework 6 and then Spring Native today, remember that they're not going to be exactly the same. So you can learn Spring Native, and those skills will translate, but the exact APIs will change. Okay, so let's see. We can do that. We can say Maven native d skip tests clean package, and we're just going to let that run off in the background. And remember, it's doing a lot of work. It's doing something called a reachability analysis. It's looking at your code. It's looking at all the code that your code uses directly, and all the code that that code uses directly, and all the code that that code uses directly, and it's creating a graph. And it's saying, okay, this type, this type, this type, we're going to keep. Everything else that we do not see at compile time that you are using, we will throw away, okay? And this is a problem because, again, you might do reflection, you might do serialization, you might do all this dynamic stuff that your compiler can't see at compile time, okay? So this reachability graph, it takes a long time to build because it's analyzing the JRE, it's analyzing your code, it's analyzing all the code on the class path. So every time you do a compile, it takes several seconds, maybe a minute or more to do this. So this is one of those things where you want to make sure that the code you compiled in Java works correctly in native. We have support for compiling your tests to guarantee that those things also line up with what you're expecting. We also have support for running this inside of a CI environment, of course, and you can use the Gravium compiler in a cross-compilation kind of scenario, for example, when you do GitHub Actions, that kind of thing. Okay, so here's the native image. Target customers. We can start this. There's our first application. Customers, there it is, right? So 61 milliseconds, 61 thousandths of a second to create an embedded database, an embedded web server, our business logic and all that, and provide the response. And of course, we can get the results by going to our customers endpoint. There you go. So we have our HTTP endpoint, we have our HTTP service. The startup time is okay. I mean, who cares, right? It's not really a use case unless you're doing serverless, in which case, have fun. Spring Native is great for that. But the really interesting part is that this now has a very small footprint, okay? So in terms of RAM. So I can use this little program, cat Josh env bin RSS by PID. And you can see that this program, all it does is ps-o RSS and then the name of the PID. And I'm just scaling some of the values that I get back to make it more presentable, okay? So we can start this, pass in the PID, and there you go. It's taking 115 megs of RAM on a Mac. Believe it or not, on Linux, it takes even less for some reason. I don't know why. So there you go. You have an application that'll work in a very, very efficient manner. It takes a very, very small amount of RAM. By the way, that 115 megs, that includes all the operating system libraries, right? That's not just my Java code. That's the networking stack in Mac OS and whatever. So that stuff is going to be copied. It's redundant. It's not like I'm actually the only person loading that. It's going to be loaded by lots of things on the operating system. And so that number is actually bigger. Your code itself is taking even less space. It's a very amazing situation. Now, of course, I want to turn that into a Docker image. So I can do that. I can go maven spring boot build -image, and that'll create a Docker image with a native binary inside of it. It'll create a Linux Docker container with a Linux binary inside of it, even though I'm obviously running on Mac or maybe on Windows or something like that. So you have lots of ways to get your application into production. Now it's out there. I want to talk to it, right? And when I do this, I want to create an edge service. And there's lots of things you can do to talk to that service from the edge. An edge service is a thing that talks to your downstream service and makes the data that's available to the outside world. For example, your HTTP, your iPhones, your Android devices, your whatever, right? All these things. So let's see here. UAO .zip, and you don't want all of your iPhones or Androids. You don't want them to all have to connect to your microservices directly. Instead, you give them this edge service, and the edge service can handle things like authentication, filtering, routing, etc. And here we can handle routing. We've created a useful edge service with a couple of different technologies that I like to use as much as possible. So port will be, let's say, 9999. And one thing I might use is Spring Cloud Gateway. Okay, gateway route locator build. Good, and I'll say routes build route rs path, and I'm going to say when somebody goes to port 9999 and they go to this URL, proxy, and then they go to URI HTTP localhost 8080 customers. Okay, when they go to this endpoint, this path, this URI, and they go to the filters here. When they go to this endpoint, we're gonna get the request at /proxy. We want to send the request to /customers on a different port. In order to make that work, we need to change the path. So I'll say change the path to be customers, because otherwise I would get something like customers /proxy, which doesn't exist, right? So I don't want that. That's why I use the filter. And these filters are where Spring Cloud Gateway is so powerful. You can do all sorts of things. You can add a rate limiter. You can add a response header, a request header. You can do add response header, etc. You can do retries. You can do all sorts of things here to make your service more robust. You can introduce headers and authentication and filtering and compression. All these things you can do very naturally here. So if we just start this Edge application up, start it, and it'll be on port, what did we say? I think we said 9999 / proxy, and there's the data from the Edge service proxying the data from the downstream service. Okay, very good. I'm on Mac M1, and because I'm on Mac OS with M1 chip, there's this weird error in Netty. If you get that error, you can just add this, and it doesn't seem to cause any trouble. So I just like to do that to make the nastiness go away. Okay, so I've got Spring Cloud Gateway. That's one way to do it, right? It's very easy to get the data, to proxy it, and so on. The next thing you might want to do is to change the data, to create a new view of the data. And so here, you could obviously create a reactive client, customer integer ID, string name, and these are my DTOs, and I'm going to create class CRM client. Okay, and I'll use the reactive non-blocking HTTP client here. I'll inject that into the constructor, and I'll say, give me all of the customers. Okay, and I'll say return this.http.get.uri http localhost 8080 customers. Okay, retrieve body to flux customer.class. Good. All right, so we've got this Spring Bean, and it's just a regular component that'll handle calling the network service for us. We're using this non-blocking HTTP client. I can also, these are non-blocking, so even though I'm making this request, the response might arrive in a separate thread. I don't have to worry about that. This is using reactive APIs. It's very clean. I can also easily compose this with other things by using, flat map and then and filter and so on. So it's easy to take the stream and as the data streams in, to transform it in some way to get a new view of the data. And so you could create a new HTTP endpoint and then proxy the data that way. You could just create another controller. However, sometimes you have different, your client has a different view of the data that they have. They want to see the data in a certain shape. Maybe they don't want all that data, okay? And this is where I think GraphQL can be very, very useful. GraphQL gives us a great way to describe our API and provide an introspectable single place where we can see how the application behaves, right? So, and see all the types in the application. So here's a sample one from SpaceX. They have different endpoints here. I can hit query and I get the data that I want back. If I don't want all the data, I can just remove some of the data and request again, and I only get the things that I care about. So here, even though there are many different microservices, capsules, cores, all these might be different microservices, I can write the query to only pull back the data that I care about specifically, right? Just these two fields, for example. It's very, very useful because now I don't have to create a new view of the data for each new client. If the Android device only needs these three fields, then great, only ask for those three fields and you don't get all the data back. If you don't need this data from this other microservice, great, don't ask for it and it will not be given to you and it will not cost you anything, right? So let's create a GraphQL endpoint. I'll create a new file here called schema.graphqls. And the root of all GraphQL applications are three well-known types. One is the query, which is what provides all the fields that can be read. The other one is mutation, which defines all the fields that operate on the server-side state that change things on the server. And then subscription is kind of like a query, but it's great for ongoing data, things like stock tickers or sensor data or the like. So here, customers, return all the customer data. This is a field called customers that returns an array of customer types. I have to define that customer type here. But notice that this doesn't have to be, in this case it is, but it doesn't have to be the same as our entity in our Java code. That's the benefit here, is that we have this little bit of indirection. Okay, so let's, okay, at controller, CRM, GraphQL controller, private final CRM client. Okay, inject that into the constructor. And here I'm going to say schema mapping, type name is equal to query, and the field is called customers. All right, so customers, this.crm.customers. Now I'm going to name this field, this method called customers. This is a handler resolver for the GraphQL schema that we just created. Okay, so I'm going to say I want to enable the same graphical console that we just saw on the SpaceX website. This graphical console is available to you in Spring for GraphQL as well. So graphical, did I change the wrong port? Oops, I forgot to define a web client bean. Builder. Okay. Okay, very good. So there's the data. And if I refresh, I get this same console, and I get this nice introspectability. I can control space, and I get the schema. So a lot of the things that people love about when they use REST, they have to add all these things like schema. They have Open API Swagger. They have different ways of composing. You have different ways of getting metadata about the systems. You have all these different things that make HTTP and REST even more complicated. And same thing for when you want to change things on a server. My goodness, how many different ways are there to do this, right? You send a post, but then you get an HTTP 200 back, or maybe you send a post and it's asynchronous. You get like a 201 and you get a location header. I mean, do you use a put or a post? You don't know. Do you use options? When do you use that? All these kind of things make REST more elegant, but also more complicated. And very few people can agree on exactly how to get it right. Do you use hypermedia or not? I mean, we don't know. With GraphQL, there's only one way to change something on the server, and you've either done it or you have not. It's not. There's no question. There's no arguing. There's no philosophy discussions to be had or anything like that. It's very pragmatic, I think. So I have a way to get all the data, but let's say I want to get profile data. Let's say I have another microservice, and that microservice gives me profiles. Okay, so here I'm going to create a new type that we don't have this microservice anywhere, but let's imagine that we did. Okay, so a microservice that just returned IDs for the profile. So for each customer, they have a profile. Let's say I wanted to create a new schema here, and I'm going to create a new type called profile. So type profile ID, okay? And I'm going to say that each customer has a profile. That makes sense, doesn't it, right? They would have a single profile. Okay, so conceptually, this belongs to the customer, but in implementation, this is actually another microservice, okay? And so I can actually create here a mono for the profile. In order to resolve that mono, I need a reference to the customer, don't I? So I say, give me a reference to the root aggregate, and I'll say, here's my new profile. Now, of course, obviously, in this case, I'm just making it up, right? I'm just returning the data in line. I'm not making a network call because I don't have an actual service. But let's imagine that I did. Imagine I'm making a network call just like I did down here. These are both returning reactive types, mono and flux. And I want to use that here. So I want to create a new endpoint that handles the resolution of the profile data for the customer. So I'd say mono of profile, and I'll inject the root customer, and I'll say return return this dot crm dot profile, passing in the customer, etc. Okay, so this is a schema mapping. I'm mapping the type and the field to this resolver method. Now, I told you that query is a very common thing. Queries are everywhere. You're going to use query types all over the place. So this is a very common thing. There's actually a shortcut for that called query mapping. Okay, this takes it assumes that the type is called query, and it takes the name of the field from the method. So this is exactly the same as this if you have this method signature. Okay, let's go ahead and restart this and we'll see what we get. Okay, so we now go here, refresh, paste, and now I got a profile. But notice that if I don't specify what subfield I want, it errors because you have to specify what subfield you want. Okay, so great. So there's my profile data. What if I don't want the profile data? Great, just run that and I get that back. So I can invoke the sub data. I can get the profile data if I want it and if I'm willing to pay the price. But if I don't need it, then I don't ask for it and I don't get it. This is why GraphQL, I think, is a great way to build integrations for all these different services that you've now deployed into the cloud. Now, one new thing that's coming in Spring Framework 6 that I'm really quite excited about is that we have a unified way to build HTTP, a declarative HTTP and RSocket based client. So let's just create a second example here. This unfortunately does not work in Spring Framework 2.x, and so I'm going to create a new project here using Spring Boot 3. I'll just bring in the reactive web support very quickly. We'll open this up, UAO edge 2.zip. Okay. Edge 2 application. And I'm supposing that I want to build another client to talk to my downstream service. And you saw over here in the Edge service that I created this CRM client. It was not a big deal. Very simple, right? I have methods here. But again, wouldn't it be nice if I had just the ability to say, hey, call this service 8080/customers and retrieve the data that I want? The web client is very, very easy to use, but again, it's just if you start to scale, if you start to create enough endpoints, this becomes very tedious. So let's create a new one, and we'll create a new record, customer integer string name. Okay. Now, some of you may have already used Spring Cloud OpenFeign or Spring Cloud Square Retrofit, both of which provide reactive declarative interface-based HTTP clients. If you're using RSocket, I created a project called Spring RetroSocket, which is in the Spring Projects experimental repository. And they both provide a way to take all three of them provide a way to take an interface and give you an actual live client that'll talk to the service. So I'm going to say, give me the customers. And in order to do this, I'll use git exchange customers, okay? Now, in the future, this will become very easy. I can just annotate it, I think, and it'll work. But for now, you have to do it yourself because it's yet, right? So I'm going to say args, and I'll inject the CRM client, crm.customers.subscribe. I'm just going to print out the results. Okay, so there's my client. I need to actually create the bean behind the scenes that'll result in the CRM client being created for me, okay? So return, and here I say HTTP service, proxy factory, okay, and then var adapter new web client adapter.forClient. I'm going to inject the reactive web client that we just learned about here. So it should be good, and it's the web client adapter, and I'm going to pass that in there, and then I'm going to say create a new client. And by the way, this can be. Right, I'm going to extract this out into a method. Okay. So there's that. And I'm going to rename this to just be service, HTTP service proxy factory. Okay, and the result, the bean, inject that here. Factory. Okay, so there's that. In order for the web client adapter to work, provide this client HTTP. So I'm just defining a separate bean here, and I'm going to inject this factory. Create client. I'll say CRM client.class. Good. Okay. So now I've got this bean. I'm going to inject a reference to it here. Let's go ahead and run this. Oops, I forgot to define the bean of the web client itself. Client.builder. Okay. What's wrong now? Oh, I forgot to specify the base URL for my web client. So, because it doesn't know where to talk to, right? So, of course, it doesn't. Base URL, HTTP, localhost 8080 / Goody. So there's our data. It's worked. Well, this is obviously a little bit verbose. My expectation is that there will be auto configuration so that you don't have to do this. You just annotate your interface or something, and you can just use it as normal that way. But anyway, hopefully this has given you a feel for some of the amazing things that are in Spring right now and the things that are coming in Spring in the future, very soon, very near future, to make building systems at scale bound for production more reliable, more easy, more concise, etc. I'm happy to answer any and all questions. I am so glad to be before you here today. I wish we could all be in person, safe somewhere, but the world is very strange right now, and I'm glad we at least can talk to each other this way. Thanks for your time.